Lesson 1. What is PostgreSQL? PostgreSQL, commonly referred to as Postgres, is an open-source, powerful relational database management system, RDBMS. It's used for storing, managing, and retrieving data efficiently. It adheres to the SQL structured query language standard, which allows users to interact with databases. PostgreSQL is known for its advanced features, full compliance with ACID properties, atomicity, consistency, isolation, durability, support for complex queries, and strong security features. Extensibility, ability to add new data types, functions, and operators. Support for multiple data types. It works with standard types like integers, strings, and dates, as well as more advanced types like arrays, JSON, and XML. Now let's start with the basics of databases and build our way up. Lesson 2. Understanding databases and tables. 1. What is a database? A database is a structured collection of data. Imagine it like a digital filing system. Inside a database, you store data in a structured way so you can retrieve and manipulate it efficiently. 2. What is a table? A table is a collection of rows and columns in a database. Think of it as an Excel sheet. Each row represents a single record, and each column represents a field of data about that record. For example, a table named employees might have the following fields: employee score ID, an integer to uniquely identify each employee; first name, a string for the first name; last name, a string for the last name; hire date, a date field. Key points: row represents one entry in the table, e.g., one employee. Column represents the type of data stored for each row, e.g., the name or ID. 3 schemas. In PostgreSQL, data is organized into schemas, which are like folders within the database. They group tables, views, and functions together. The default schema is usually named public. Lesson 3. Installing and accessing PostgreSQL. 1. Installation. Skip if you already have it installed. PostgreSQL is available on all major operating systems: Windows, Mac OS, Linux. You can download it from PostgreSQL's official site, https://www.postgresql.org/download/. 2. Accessing PostgreSQL. After installation, you'll use an interactive terminal or a graphical tool like pgadmin to interact with the database. Terminal access. PostgreSQL provides a command line interface called PSQL. It allows you to run SQL queries directly from the terminal. Here's how you connect. Bash psql-u postgres. In this command, psql is the tool. -u specifies the user. Default is Postgres. You will be prompted for a password. Graphical tool, pgadmin. For those who prefer a visual interface, pgadmin allows you to manage databases, tables, users, and more via point-and-click actions. Lesson 4. Basic SQL, structured query language. SQL is the language you use to interact with PostgreSQL. Let's start with the basic SQL commands. 1. Creating a database. Before we create tables, we need a database to store them in. To create a new database, run SQL create database mydatabase. This creates a database named mydatabase. In SQL, commands are case-insensitive, though convention is to write keywords like create, select, etc. in uppercase. 2. Creating a table. Once the database is created, let's create a table inside it. SQL create table employees, employee or ID serial primary key, first name varchar 50, last name varchar 50, hire date date. Serial automatically increments the employee ID field. Primary key uniquely identifies each row. Varchar 50 limits the string length to 50 characters. Date specifies the column as a date type. 3. Inserting data into a table. To add records, rows, into the employees table, use the insert command. SQL insert into employees, first name, last name, hire date, values, John Doe, 2023-01-15. This adds a new employee named John Doe, hired on January 15, 2023. 4. Querying data. To retrieve data, use the select statement, SQL select from employees. This fetches all records from the employees table. 5. Updating data. You can update records using the update command. SQL update employees, set last name equals Smith, where employee core ID equals 1. This changes the last name of the employee with employee ID 1 to Smith. SHA-6, deleting data. To remove a record from the table. SQL delete from employees where employee ID equals 1. This removes the employee with employee ID 1 from the table. Lesson 5, constraints and data integrity. PostgreSQL provides several mechanisms to ensure that the data you store is valid. 1. Primary key constraint. As seen earlier, a primary key ensures that each row in a table is unique. It doesn't allow duplicate or null values. 2. Unique constraint. Ensures all values in a column are different. SQL create table departments, department core ID, serial primary key, department name varchar 100 unique. 3. Not null constraint. Prevents a column from having null values, i.e. blank. SQL create table projects, project ID serial primary key, project name varchar 100 not null. 4. Foreign key constraint. Links two tables, ensuring that the data in one table corresponds to the data in another. SQL create table department employees. Employee ID int references employees, employee ID. Department ID int references departments, department ID. References. Establishes a relationship between tables. In this case, it ensures that department ID and employee ID exist in their respective tables. Lesson 6. Advanced SQL queries. Now that we've covered the basics, let's dive into more complex queries. 1. Filtering data. You can filter records using the where clause. SQL select from employees where hire date 2022 JAS0101. This returns employees hired after January 1st, 2022. 2. Sorting data. To sort results, use order by. SQL select shop from employees order by hire date desk. This retrieves all employees sorted by the hire date in descending order. 3. Joins. Joins are used to retrieve related data from multiple tables. SQL select employees.firstname, departments, department name, from employees, join department employees on employees.employee ID equals department employees.employee ID. Join departments on department employees.department ID equals departments.department ID. This query retrieves employees along with their corresponding department names by joining three tables. Lesson 7. Working with indexes. Indexes help speed up query performance. When you create an index on a column, PostgreSQL can find data faster. 1. Creating an index. To create an index on a column, SQL create index IDX hire date on employees hire date. 2. Removing an index. SQL drop index IDX hire date. Lesson 8. Views and transactions. 1. Views. A view is a virtual table based on the result of a query. It simplifies complex queries. SQL create view employee department as select employees.firstname, departments, department name from employees, join department employees on employees.employees.id equals department employees.employee ID. Join departments on department employees.department ID equals departments.department ID. 2. Transactions. A transaction allows you to execute multiple SQL statements as a single unit of work. It ensures that either all operations succeed or none do. SQL begin. Update employees. Set last name equals Brown, where employee ID equals 2. Delete from departments where department ID equals 3. Commit. Lesson 9. PostgreSQL data types. Overview. PostgreSQL provides various data types to store different kinds of information in your database. Each data type is used for specific kinds of data like numbers, text, dates, or even arrays. Below are the major categories of data types in PostgreSQL. 1. Numeric types. These types are used to store numerical data like integers, decimals, and floating point numbers. Integer, int, stores whole numbers, both positive and negative. Example, create table products, product ID serial primary key, price integer. This allows you to store a whole number like 1000 or -50. Real and double precision, used for numbers with decimal points, floating point numbers. Example, create table measurements. Measurement ID serial primary key, height real. This stores values like 5.75 or 180.23. Numeric decimal, used when you need exact precision, like in financial data. You can specify how many digits in decimal places. Example, create table finances, finance ID serial primary key, amount numeric 10-2. Numeric 10-2 means the number can have up to 10 digits total with 2 decimal places, e.g. 1, 2, 3, 4, 5, 6, 7, 8.90. 2. Character types. These types store text strings. Varchar n stores variable length strings with a maximum length of n characters. Example, create table customers, customer ID serial primary key, name varchar 50. This allows a string with a maximum length of 50 characters. Text stores text of unlimited length. Example, create table reviews, review ID serial primary key, review text. This can hold long text such as detailed reviews or descriptions. 3 date-time types. PostgreSQL offers powerful types to handle dates and times. Date stores calendar dates, year, month, and day. Example, create table events, event ID serial primary key, event date date. This stores a specific date like 2024-1225. Time stores the time of day. Example, create table schedules, schedule ID serial primary key, start time time. This stores a specific time like 14:30, 2:30 p.m. Timestamp stores both date and time together. Example, create table appointments, appointment ID serial primary key, appointment time timestamp. This stores both date and time like 2024-09-10, 14:30. Interval represents a span of time, like the difference between 2 timestamps. Example, create table durations, duration ID serial primary key, duration interval. This could represent something like 2 hours 30 minutes. 4. Boolean type stores logical values, true, false, or null, if no value is set. Example, create table tasks, task ID serial primary key is completed Boolean. This can store whether a task is completed true or not, false. 5. Array type. PostgreSQL allows you to store arrays, which are ordered lists of values. Example, create table employee skills, employee ID serial primary key, skills text. This stores an array of strings, for example, SQL, Java, Python, representing different skills of an employee. This breakdown of data types will help you understand how different kinds of data are stored in PostgreSQL, from numbers and text to dates, times, and even arrays. Lesson 10. Functions and expressions in PostgreSQL. PostgreSQL Functions Overview. PostgreSQL has built-in functions and operators to perform various calculations and manipulations on data. Here are some of the most common functions used. 1. Aggregate functions. These perform operations on a set of rows and return a single value. Some key ones include count, counts the number of rows in a table. Example, select counts from employees. Sum, adds up the values in a column. Example, select sum salary from employees. AVG, calculates the average value of a column. Example, select AVG salary from employees. Max and min, find the highest and lowest values in a column. Example, select max salary, min salary from employees. 2. String functions. These functions are used to work with and manipulate text data. Upper and lower, convert text to upper or lower case. Example, select upper first name from employees. Length returns the number of characters in a string. Example, select length first name from employees. Concat joins strings together. Example, select concat first name, last name as full name from employees. 3. Date functions. These functions help work with dates and times. Current date returns the current date. Example, select current date. Age calculates the difference between 2 dates. Example, select AG hire date from employees. Date part extracts a specific part like year or month from a date. Example, select date part year hire date from employees. 4. Mathematical functions. Perform various calculations on numeric data. Round rounds a number to the nearest integer or specified decimal places. Example, select round salary to from employees. ABS returns the absolute value of a number, removing any negative sign. Example, select ABS 5. Lesson 11. Transactions in PostgreSQL. What are transactions? A transaction is a sequence of database operations that are treated as a single unit. Transactions in PostgreSQL follow the ACID principles. Atomicity, all operations succeed or fail as a group. Consistency, the database remains in a consistent state before and after the transaction. Isolation, transactions do not interfere with each other. Durability, once a transaction is completed, the changes are permanent. Transaction control commands. 1. Begin, starts a transaction. Example, begin. 2. Commit, finalizes and saves changes made in a transaction. Example, commit. 3. Rollback, reverts changes made during a transaction. Example, rollback. Example transaction. Example scenario, increase salary by 10% for Department 5 and delete an employee with ID 100. Begin, update employees. Set salary equals salary cell 1.1 row, where department to ID equals 5. Delete from employees, where employee ID equals 100. Commit. If something goes wrong, use rollback to undo the changes. Save points in transactions. Save points allow you to undo part of a transaction without affecting the whole transaction. Example, begin. Insert into employees, first name, last name, values, Alice Doe, save point 1. Insert into employees, first name, last name, values, Bob Smith, roll back to save point 1. Removes Bob but keeps Alice. Commit, Lesson 12, User Management and Security. Creating users and managing permissions in PostgreSQL. 1. Creating a user. Use the create user command. Example, create user new user with password secure password. 2. Granting privileges. Use grant to give users access to tables or databases. Example, grant select insert on employees to new user. 3. Roles. Roles are sets of privileges that can be assigned to users. Creating a role. Create role manager role. Granting privileges to role. Grant select update on employees to manager role. Assigning role to user. Grant manager role to new user. 4. Revoking privileges. Use revoke to remove access. Example, revoke insert on employees from new user. Lesson 13, Backup and Restore. Backing up and restoring a database in PostgreSQL. 1. Backing up. Use pgdump to back up a database. Example, pgdump my database backup.sql. 2. Restoring a database. Use PSQL to restore from a backup. Example, PSQL my database backup.sql.